Section 5.2, using perpendicular bisectors. Remember, the word bisector means cut into two pieces, okay? Let's read. A segment bisector intersects a segment at its midpoint. There's our first typo. It's midpoint. Okay, a segment bisector intersects a segment at its midpoint. Midpoint is middle. Okay, write that down if you don't remember it. Midpoint is middle. A segment, ray, line, or plane that is perpendicular to a segment at its midpoint is called a perpendicular bisector. Our example. Here is a line perpendicular to a segment at its midpoint, which is P in this case. Okay, I have a line perpendicular to a segment at its midpoint, means these are equal. Okay, so line C is a perpendicular bisector. Okay, we're actually going to call it CP because there's a P there too. CP is a perpendicular bisector of segment AB. Okay? Also, a point is equidistant from two figures if the point is the same distance from each figure. So a point is equal distance from two, and we're going to do these figures are going to be squares. A point, that's not even equidistance. Let's erase this one and move it in a little. A point is equidistant from two figures if the point is the same distance from each figure. Point, same distance from each figure. The figures are the squares. Okay? Also, points on the perpendicular bisector of a segment are equidistant from the segment's endpoints. So let's just do this. I have a point on the perpendicular bisector. It is equidistant from the segment's endpoints. Cool? We'll say this is a point D. Next. Theorem 5.2, the perpendicular bisector theorem. It's a theorem that says a lot of what we just said. In a plane, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Talk through this. If a point is on the perpendicular bisector of a segment, this is a perpendicular bisector because it's perpendicular and it cuts a segment into two equal parts. Perpendicular bisector, perpendicular, cuts a segment into two equal parts. If a point is on that perpendicular bisector, it is equidistant from the endpoints of the segment. Okay, so if CP is the perpendicular bisector of AB, then CA is congruent to CB. Rewind that if you need to hear it again. All right, Theorem 5.3, the converse of the perpendicular bisector theorem. So, in a plane, if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. Let's say that again. Let's look at the diagram. If a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So if DA is equal to DB, then D lies on the perpendicular bisector of AB, where CP is the perpendicular bisector. Okay, let's do an example. BD is the perpendicular bisector of AC. Find AD. So BD BD is the perpendicular bisector of AC. So because of Theorem 5.2 and 5.3, we know that AD is equal to CD. Okay, so now let's substitute. AD is 5x, CD is 3x plus 14. Subtract 3x from both sides. Divide both sides by 2. We have x equals 7. That doesn't mean we're done, though. We're trying to find AD. We need to substitute 7 back in. AD equals 35. Okay, in the diagram, WX is the perpendicular bisector of YZ. So I can say that this segment and this segment are congruent. WX is the perpendicular bisector of WZ. I can also say that these are congruent. Okay, what segment lengths in the diagram are equal? Hey, I've already marked them. We know that part A is XY is congruent to XZ because WX bisects YZ. Say that again. WX bisects YZ. So XY and XZ are congruent. Also, because W is on the perpendicular bisector of WZ, W is on the perpendicular bisector of WC, we can also say that WY is congruent to WZ because of Theorem 5.2. Okay? And in the diagram, we see that WV is congruent to VZ because they are both 25 units. That's their measurement. Okay, part B. Is V on WX? We know that YV equals 25 and VZ equals 25. So YV is congruent to VZ in that converse theorem. Theorem 5.3 says if these two pieces are congruent, then this point lies on the perpendicular bisector. So yes, let's say that again. I can't erase it now, sorry. If these two segments are congruent, then point V lies on the perpendicular bisector. Okay, the U-try has 3 parts. So this is part 1. So in the diagram, JK is the perpendicular bisector of NL. What segment lengths are equal? Explain your reasoning. Go ahead and push pause and try this one on your own. Okay, there's your 3 answers. Go ahead and push pause and read through them. Another U-try. In the diagram, JK is the perpendicular bisector of NL. Find NK. Okay, push pause and go ahead and try it. Okay, there we go. NK equals LK because of Theorem 5.2. So I set both of those equations equal to each other and solved for x. Got x equals 3. Plugged that back into the equation for NK and got NK is equal to 13. Explain why M is on JK. Go ahead and push pause. Big explanation. Since ML is equal to MN, M is equidistant from N and L. So because of Theorem 5.3, M is on the perpendicular bisector of NL, which is JK. Okay, read through that again. Okay, video break, and we'll start the next video in a minute.